So today let's take a look at this problem, car fleet. So the statement is very simple and it's very straightforward. So there are n cars traveling to a particular target mile. So there is a set of cars traveling to a certain target. So we are given the input for our problem is we are given two arrays and we are given an integer. So we were given the position array and we are given the speed array and we are given the target integer. So in the straight up in the position array, the position array denotes the current position of the following cars, and the speed array denotes the speed of the following cars. And every in the position array, the ith element denotes the ith position of the ith car, and the speed array it is the same. Now, without further ado, what we have to do is we have to now return the number of car fleets that will arrive at the final target destination. So now let's take a look at what is a car fleet. So as per given here, a car fleet is nothing but a group of cars traveling like parallel or traveling together. So here, as per the rule of the problem, each and every single car in this list will be traveling to a particular destination, and while traveling a car cannot overtake another car. So let's say if a car is at position 10 now, then it cannot over a car which is going in the forward position or in the forward thing. What the car can do is the car can go with along parallel to that car. Okay, it cannot just overtake that car. So that is the main rule for this problem. So what cars will be doing is, if this car arrives at the speed of this car, then the both of the cars will be traveling together. So if similar to that, if the both of the cars are traveling together, then it is a car fleet. So what we have to return is we have to return the number of car fleets that will arrive at the final destination. Okay, so we got the problem clear. So the logic is straightforward. So let's take a look at the logic. Okay, so before going to the deep into the logic, let's take a quick overview on the depth of the problem understanding. Okay, so what I mean by is, let's just take this input for example. So the target value should be 10, and these are the list of car position of the cars, and these are the speeds of the cars. Okay, so now as per this problem, let's take this sheet as an example. So here, this is target value. So 10 is the last mile, and we are starting from 0. Okay, so these are the cars traveling to the last final destination. So here, if we take a look at the last car over here. Okay, so this is the last car. So as we take it, we have to, so let's be clear on what you have to find. We have to find the number of car fleets. Okay, so we have to check if these two will merge and make a car fleet. I have to check if the group of cars, so we have to check basically if we have group of cars will merge and make a car fleet. So how to check that, and how to confirm that, how to check if these two cars will make a car fleet. Okay, so that's what we're going to see now. So let's say this is the first car, last car we're encountering here, which is which is at position 7 and which is traveling at 1 mile per hour. Okay, let's just have it the speed as 1 mile per hour. Now here, since it is at position 7, the distance that it has to travel is just 10 minus 7, 3. So the distance that the first car has to travel here is just, the distance will be 10 minus 7, which will be 3, correct? Yeah, now the distance it has to travel is 3. Now since it is going at 1 mile per hour, it will reach position 10 by 3 hours, correct? So as per our formula here that we all know, now what is it going to do is we're going to calculate the time for each car to for each car to reach the given target value. So we're going to calculate the time. So usually what we know is time will be distance by divided by speed. Since we know the distance and speed for each and every single car, the calculating the time is very easy. As we calculated the distance here, the speed is 1. So the time for the last car to reach its time will be 3 by 1, 3 by 1, sorry, which will be 3. Correct. So now the time, since the time taken is 3, let's just keep it there for now. Now let's calculate the time taken for this car. Let me just put this above here. Now let's just calculate the time for this car. So the time will be, so the time will be 10 minus 4, which is will be the distance, divided by 2, which is the speed, which will be, as per the calculations, will be 6 by 2, which will be 3. So it the both the speed of this the time taken by this car and this car to end to end to reach the target value is the same. So since this car is traveling at the same speed, this will make a car fleet. I'll explain why, okay, since the time is different. So now let's take the time for this car, okay. So let's say this will be traveling at 9 by 2, correct. So time will be 10 10 minus 1 divided by 2, correct. So which will be, let me just give the time alone, which will be 10 minus 1, 9 by 2 will be 4, correct. Now this is taking 4 hours. Since this car is taking only 3 hours to reach the end, okay, and this car is a little bit slower, it will take 4 hours to reach the end. So these two things will not make a car fleet, okay. Since this car will end up reaching the final destination, but this car will still have a hour left to reach. So these two cars will not make a car fleet. So let's calculate the time for the last car. So since it is traveling at 1 mile per hour, it will take 10 hours. So time will take, it will take 10 hours to reach the thing. So let's just calculate how many car fleets from the information we got here. Let's just calculate how many car fleets we are getting. So since the time for this both are same, we can consider this as a car fleet. And here, since the time for this car is way is 1 hour more than this car will just be this will end up reaching the finishing line when this car is still has 1 hour left. So these two things will not make a car fleet. And the last car is just traveling up very slowly, and it has 10 hours to reach it. Since the time is way above than this car, then these two will not also make a car fleet. So there are 3 car fleets in total in this program. So that is why the output is 3. Okay, this is the detailed view of what we are going to be doing here. We are going to be calculating the time, and based on the time we are going to be determining the number of car fleets. Okay, so into the detailed view, into the logic. So moving to step 1. Step 1, what are we going to be doing is, we're going to be taking each and every single car by the position and speed. So we're going to be pairing the position and speed, and we're going to be putting it in an array. Okay, so let's take the input first. The input is mismatched, but here in the pairs array, we have it ordered, like we have 7 comma 1 and we have 4 comma 2. It is in a descending order. Okay, so let me tell you why we're going to be solving this. We're going to be taking this pairs array in a descending order. Okay, so we're going to sort it in a descending order. I'll tell you why. Here, if you see here, what we're doing here, we're calculating time from the last point of the last element of the array. Because why? So why are we going to be taking the pairs array, this combined thing, in a descending order is, we're going to be calculating the time from the last element. Because if we just start doing our time calculation from the first element, what we'll be doing, we'll be calculating the time for this one, and we'll be comparing, will this be a car fleet, correct. But this car could eventually merge up with this car, and the speed will change. Since this in this example the speed is same, but let's take a look at this example. Okay, let me say this is like the speed is, the position is like at 5. Let's say the position is at 5. Then this the speed, the time taken will be 2.5, correct. Since this is 2.5, this car will eventually be merging with this car. Okay, it will eventually be merging with this car, and it will travel at the pace of speed of this car. So the speed of this car will change. So because of that reason, we are taking the array from the right hand side. What I mean is, we'll be doing our calculation in a descending order. So for that, so what the first step we are going to follow is, we're going to create this pairs array. Okay, we're going to create this array based on the speed. We're going to take based on the cars. Okay, each element will have the position of the car and speed of the car. Okay, we're going to create this in a reversed order. Okay, as per our logic here, we'll create this in a reversed order. The second thing we're going to be doing is we're going to go for a stack approach. Okay, so let me just get rid of this real quick. Here, the thing we're going to be doing is, let's say the logic behind I have said that we're going to be calculating the time here. With based on this time, how are we going to determine if these two will be a car fleet or not? So let me just take this as 5 itself instead of 4, since it is a better example. So let me just take this as 5. Okay, here let's say first we're going to be calculating the time for this one. Okay, at one point of time it'll reach the finishing point 10. It'll reach at 3 hours. So we're going to be putting the 3 hours in our stack. We're going to be putting the 3 hours in our stack. Okay, now after this, what we're going to be doing is we're going to calculate the time for the next one. The next one is going to will reach at 2.5 hours. So instead of putting it in the stack, so since it reaches at 2.5 hours, these two elements are going to be in the same car fleet. These two cars are going to be in the same car fleet. Now how we are saying that it's going to be in the same car fleet? Since the time is lesser than this time. The time for this car to arrive is 3 and time for this car to arrive is 2.5. Since the 2.5 is less than 3, this cars going to end up this car is going to eventually catch up with this car, and these two cars will be traveling at the same pace. So these two will end up in a same car fleet. How we are calculating it? The time is lesser than the time taken to reach a finishing point is less than the time taken for this car to take the cross the finishing line. Correct? This is how we're calculating that these two cars are the same car fleet. So since these are the same car fleet, since the timing is less, we don't have to append it to the stack. Okay, this stack is gonna take this stack is gonna track how many car fleets are there. Okay, so let's jump on to the next element. This car will take 4 hours to reach the top. Since 4 is a greater number than 3, since 4 hours is uh, since 4 is a greater number than 3, these two car fleets will end up reaching the finish line by 3 hours. But this car has 4 hours in it. So this car will travel in a different pace. So this is another car fleet. So we're gonna add 4 in the stack. Now next thing is we have to calculate the last one. The last one will reach the end by 10 hours. So that thing, since the it is 10 is greater than 4, we're gonna append it to the into our stack. Okay, now this track previously what I said this stack keeps a track of how many car fleets are there. Now there are 3 car fleets. At the end we just have to return the number of elements in our stack. Okay, the main and the thing we have to follow here is we have to we should not we should not have any numbers less than the previous number here. So we don't, since we have 4, see what I'm trying to tell here is 4 is greater than 3 and 10 is greater than 4. We should have instead of 4 we should not have any car fleets. We should not have any car fleets which is traveling in a speed of less in a which is traveling in a speed of less than 3 here. Okay, because that car fleet will eventually get merged to this 3 car fleet. So this is the stack we're going to be maintaining, and this is the logic, guys. So let's real quick let's try to code this. Okay, so let's just jump right into the first step. The first step is to create the pairs array, so that I have all of my cars in the pairs array. So let me just have an array here. So here what I'm going to do is I'm just going to make an array. So what I'm going to have the position, and I'm going to have the speed. So I'm going to loop through both of the arrays and just create this pairs array. So I'm going to loop through. I'm going to have the variable p and I'm going to have the variable s. Now here for ps in. So what I'm going to do is I'm going to use a function called zip. I'll tell you what this function will do. So what this function will do is, basically do is, so I've given two arrays here, position array and speed array. So it will take each an element from the position and speed array, combine it as a single element, single array, and then put it and give the value as p and s. So first time p will be whatever is in the position array, and s will be whatever is in the speed array. So it will combine both of the values and return as a whole value. So this is how we are going to create this code. Basically what it does is it creates this array. Okay, so since we want this only creates the array, we want the reversed version of it. So we want to sort it. So I'm going to sort the array, pi pairs dot sort. So I'm going to sort it in a reversed version. So for that I have to have reversed. I have to put it as true. Okay, looks good. Now the next step that we have to follow is we have to have our stack to keep track of the car fleet. So I'll have my stack as an empty array. I'll have it as an empty array initially for now. So the declaration part is done. So what you have to do is, the next part is we have to loop through this pairs array and then do our calculation. So let me do loop through the pairs array for p and s. Why don't we just take the space out here? Pairs. I think that's basically it. In pair. Yeah. So here the first step that you have to follow is we have to append the time. We have to append the time of each and every single car to reach the destination to our stack. So let me just append the time. Let me just put stack dot append. Let me up so I have to append the time. What is time? Basically it's distance by time. So let me just calculate the distance, which is target minus our current position divided by our speed. Now here what I'll tell you here, we have to have this target. We have to do this division. Okay, just like this we have to calculate the time. So I'll just have braces here so that this operation gets done first, and that's it. So we just have to append. The next thing that we have to do is we have to check. So the next thing that you have to do is, so since we are appending every single time here, if as per our drawing here, if the car fleet timing is less than the previous car fleet timing, then we should remove it. Then we should not append it. For that what I'm doing is I'm having a condition here. The thing is, if it is less than the car fleet timing, yeah, then we have to remove it. So if stack of -1, this is how to get the topmost element of the stack, is less than stack of -2, then we should, sorry for the bracket. I was recording a lot in Java, so I just got added to the bracket. So if it is less now, then we have to just remove it. Stack dot pop. Good. So now there's another condition here. We only have to do this if our length of our stack is greater than or equal to 2. So I'll tell you why we are checking the length also here. Let's say here in this example, we have to remove the element only if our stack length is above 2. So let's above or equal to 2. We should not remove the first element here. If the stack if the first element is less now, then we should not remove it. We should only remove the second and upcoming element. So that's why we're putting that condition there. Let me just go there real quick. Okay, here this is the thing that we have to follow here. The last thing that you have to do is, after every operation is done here, we just have to return the length of our stack. Okay, so let's see for the test case pass. Okay guys, there's a little bit of problem here. So there's a corner case that our code is stuck at. Okay, let's take a look at this corner case real quick. So as per our code, our output is 1 but the expiry is 2. Okay, the reason why this is happening is, let's take a look at this input real quick. So the position has 6 and 8 and the speed is 3 and 2. So what will get appended to the stack? 10 minus 6, 4, 4 by 3. 4 by 3, what will be? It will be 1 point something, correct? But here, but he- but here, since we are doing an integer division here, 1 will get appended to the stack. And if you go to the next one, recalculate the timing. 2 by 2, 2 by 2 is 1. So since both are at the same speed, same time, both will reach at the same time, it will take into an account that this is a one this is it is a same car fleet, but it is actually not a same car fleet. So for that, what you have to do is, you have to take account of the float decimal value. For that, I'm changing this. We are what we are doing here, we are just calculating the distance. No, I'm changing the distance to a float value, since the decimal value will get calculated. Now if you try to run the code, all the test case passed. Okay, we beat 37% of the users. So that's all I have for today, guys. Thank you for watching. See you guys in the next time.